Good afternoon to all my YouTube viewers. In this video, I'd like to discuss about test paper 4 on physics. Now, let us start the first job. Two concave refracting surfaces of equal radii of curvature and refractive index 1.5 face each other in air as shown in figure. A point object O is placed as shown in figure. What is the separation between the images of O formed by each refracting surface? You can see object is placed at O. Two glass spherical surfaces. Object is at O. We have to find out image formed due to refraction on this right side glass, then due to refraction on left side glass. Then we have to find out distance between the images. Distance between the images. Now to do this we can see first we will take refraction on the right side glass and then we will take refraction on the left side glass. Now object distance here is, you can see from here pole to here, object is here, and from second glass it is this distance AO, and from here BO. Now we know the general formula for refraction, that is mu2 by V minus mu1 by U equal to mu2 minus mu1 divided by radius. Here U means object distance. Object distance for this will be negative according to sign convention. Direction of light taken as positive, minus R by 2 will come, and mu2 will be glass refractive index 1.5 divided by V minus 1 by minus R by 2 equal to 1.5 minus 1 divided by R by 2 divided by R. R also negative because its radius is this side, so it will be negative. Now simplifying here, we will get V equal to minus 3 by 5 R will come. Now similarly for the left side glass, we will get mu2 by V dash minus mu1 by U dash equal to mu2 minus mu1 by R. In the same manner, we will do that 1.5 divided by V dash minus 1 by minus 3 by 2 R equal to 1.5 minus 1 divided by R. Minus 3 by R, you know that distance from A to position O is R plus R by 2, that means 3R by 2, and negative because it is against the direction of light. Now solving here we will get minus 9 by 7R, and distance between the two glasses is twice R, as it is being shown here, that this is 2R. From A to B it is 2R. That means we can find out 2R minus left hand side glass image formed minus 9 by 7R, and the right hand side glass image will form minus 3 by 5R. Simplifying these, we will get 4 by 35R. 4 by 35R. Now distance between the images will be, say, capital D, that is 0.114 R. Answer is C. You have seen that answer will be C, this one. Now next job. If momentum P, area A and time T are taken to be the fundamental quantities, then energy has the dimensional formula. We require to find out dimensional formula for energy. So energy is, we know, m L square T to the power minus 2. From here energy and work has same unit, from here we can find out for ml t to the power minus 2, ml square t to the power minus 2. From here we can write ml t to the power minus 1 and L t to the power minus 1. For this it is momentum. ml t to the power minus 1 is momentum replaced by P, and L can be replaced by root a to the power half, and T as usual t to the power minus 1. So this is the expression for energy when fundamental unit is P, A and time. Momentum, area and time. And this is number D is the choice here. P to the power 1, T to the power A to the power half, T to the power minus 1. Now next job. A system consists of a uniformly charged sphere of radius bigger and a surrounding medium filled by a charge with the volume density rho equal to alpha by smaller, where alpha is a positive constant and smaller is the distance from the center of the sphere. Find the charge of the sphere for which the electric field intensity outside the sphere is independent of capital R. We have to find out charge when electric field intensity is independent of R. Under this situation we have to calculate. For charge dq we can write down 4 pi small r square into dr, that is volume, small segmental shell volume, that is 4 pi r square dr, into density will give mass of that shell, and rho is given alpha by r. We can substitute this one and we will get this type of expression, that is 4 pi alpha rho smaller dr. Now integrating from 0 to capital R we will get this one, 4 pi alpha into r square by 2. That means it will give us 2 pi alpha r square, 2 pi alpha r square amount of charge present on the whole sphere distributed from center. Now electric field is known, that E dot ds closed integration q by epsilon, q is known 2 pi alpha into r square by epsilon naught. From here E is available on the surface of the sphere will be alpha divided by twice epsilon naught, which is independent of radius. No radius is here. So charge involved will be q equal to 2 pi alpha r square. That will be the answer. Answer will be C. You can see here C. Now next job. The bob of a simple pendulum is spherical hollow ball filled with water. A plugged hole near the bottom of the oscillating bob gets suddenly unplugged during observation till water is coming out. The time period of oscillation would be. Now as soon as unplugged, its time period is known 2 pi root under L by G. L will start increasing because effective length when it was totally filled, its effective length up to the center of the bob. Now as soon as water coming out, the effective length will increase. Once the entire liquid comes out, then effective length returns to its original position. So time period again decreases. This is the way we can explain. This is a simple one. Now C will be the answer. When L increases, time increases. When L decreases, it returns to original value of time period. So that is the point here. Now answer C here. Now come to job number 5. Two long parallel wires are at a distance twice d apart. They carry steady equal currents flowing out of the plane of the paper as shown. The variation of the magnetic field B along the line XX dash is given by. In the diagram it is given to two small dot here and here, and these two dots are the cross section of the current carrying wire. Current goes up, current is perpendicular to the plane of the paper. So magnetic field around upward current, this one we can draw a anti-clockwise circle, tangent will give the direction of current. Now if you draw tangent here, you will see it will give upwards. Now closer to this wire it is upwards and higher the magnitude, and if we go from x to x dash, in between somewhere here, for this one also it is anti-clockwise circle has to be drawn. Magnetic field here will be downwards, and for this wire already you have seen upwards. So there will be a null point in between the two current carrying wires. So null point is available here. Now as it approaches towards x dash, I mean here, then this will dominate over this one, other one. So magnetic field will be on third quadrant, and here it is first quadrant. Now this among both the diagrams shown almost same for this portion of the, and these two cannot be answered because null point is not available here, in one direction only, either upwards or downwards. These two diagram cannot be. Among these two we have to see the correct one. Now let us see how we can do these jobs. Here current is equal, steady current. Distance between them is twice a. Both currents upwards. These are the informations. Now if we are in between, already known null point will be available. This side first quadrant, B magnetic field will be in the first quadrant and dominate over the other one, and here it will be on the third quadrant and it will dominate over the other one. That part is okay. Then come to right side of the wire here, and as current goes upwards and magnetic field will be anti-clockwise, tangent will give the direction of magnetic field. Here it will show upwards. If you draw a circle around it, tangent to be drawn anti-clockwise, so it will show upwards, magnetic field upwards, and this magnetic field will dominate over this, so resultant will come upwards. Now it is a pattern, maybe 1 by distance, maybe the pattern we have to check. Now here same thing, anti-clockwise circle can be drawn here, and tangent will show here downwards. That means this current will show magnetic field, it will dominate over the other one, so resultant will be on the third quadrant. So this will be the correct one. In the choices we can see one more diagram is given here. This one, this cannot be. Answer will be B. This one, because we can see that resultant resultant magnetic field has to be in the first quadrant. For this effect of both will be first quadrant. Here it will be third quadrant. That is the difference between these two. You can see this is given fourth quadrant, this is second quadrant. That is not possible. This is the answer. Now come to job number 6. A photon collides with a stationary hydrogen atom in ground state inelastically. Energy of the colliding photon is 10.2 electron volt. After a time interval of the order of microseconds, another photon collides with same hydrogen atom inelastically with an energy 15 electron volt. What will be observed by the detector? What will observe by the detector? Now for the first photon, we can see it has energy only 10.2 electron volt. Now to remove electron, minimum energy required to remove the electron from ground state is known, that is 13.6 electron volt, but it is much less, 10.2 electron volt here. So this photon cannot remove electron. It will strike the electron and it will bounce back. I mean that photon will come out from the system with same energy. It cannot eject out electron from hydrogen atom. Now another photon is being fired, and that photon has energy 15 electron volt. It means it is more than 13.6. So this photon will be able to eject out one electron from the hydrogen atom, and remaining energy will take the photon and it will come out from the system. I mean total energy is 15 electron volt which has come from photon. 13.6 electron volt will absorb by the electron to come out from the orbit, from ground state. So remaining is how much? 15 minus 13.6, that is 1.4 electron volt energy will left with the photon and it will come out of the system. I mean this electron, now here choice is one photon of energy 10.2 electron volt and an electron of energy 1.4 electron volt. Yes, this can be the answer. Next, two photons of energy, it cannot come out two photons. One photon will be given out its energy, so only one photon will come out which is not absorbed by the hydrogen atom, and here electron will come out after taking energy, residual energy of the photon, that is 1.4 electron volt. A is correct here. Two photon energy, no. One photon of energy 10.2 and another photon 1.4 electron volt. No, electron will come out. This A is answer. A is answer. You can explain in this way. That means detector will observe a photon with energy 10.2 which is not being absorbed in the system, and an electron with 15 minus 13.6 electron volt will come out from the system. Now job number 7. Here two masses are connected by a string as shown in the figure over a frictionless pulley. The acceleration of the system is, we have to draw free body diagram. After drawing free body diagram, find out common acceleration like this. Say it will move in this direction, then m1g, say this is m1, 8 kg. m1g is sin 30 minus t into m1a, you can say. Now why it will go up? Because tension will be more than this m2g, t minus m2g equal to m2a. Solving here you can see m1 sin 30 minus m2g, this will come. m1 is 8 into half, sin 30 is half, minus 4. Ultimately a is coming 0. That means no acceleration will take place in this case. Now here C will be the answer. Next job, photoelectric effect experiments are performed using three different metal plates, P, Q, R, three different metal plates having work function 2 electron volt for P, for Q 2.5 electron volt, and for R it is 3 electron volt. for 550 nanometer, for 450 nanometer. And 350 nanometer with equal intensities illuminated each of the plates. The correct IV for the experiment is current versus voltage plot. Now, for this job, we have to see 3 different wavelength light is falling on the plates. We have to see how much energy involved with each wavelength. By this way we can calculate. E1 will be Hc by, this is 550, that means it will give 2.55 electron volt, and for E2 will be 1240450, that means it will have energy 2.75 electron volt. The incident ray which is available, it has initial, one of the wavelength has energy 2.55 electron volt, other one has 2.75 electron volt. For 350 wavelength nanometer, it will have a 3.54 electron volt. That means, according to work function is given here, for P 2 electron volt, for Q 2.5 electron volt, for R 3 electron volt. That means the energy which is available, this energy is not able to eject out electron from Q and R. This energy is not able to eject out electron from P metal as well as Q metal as well as R metal, but from P it can eject out. This is the highest wavelength, lowest energy available from this. Then this metal, I mean E2, which is 2.75, it won't be able to eject out electron from R metal, but it can eject out electron from P as well as Q. And this one can eject out, I mean third one, which has lowest wavelength, highest frequency, that means 3.54 electron volt. This one can eject out electron from all 3 metals. Now from here, what can we conclude? That means work function of P is lowest, that is only 2 electron volt. Now, as it has lowest work function, so it will have a maximum stopping potential and saturation current will be maximum, because work function lowest means it will have a higher stopping potential. So we will get, if you see this plot here, P metal will have a higher saturation current, because lowest work function means it can use most of the energy to release maximum current. Saturation current will be more, as well as stopping potential will be more. For Q, it is the second position, I mean saturation current compared to metal P, it is less, but stopping potential again it is less than P. That means Q will be in between, and R is the highest stopping potential, highest work function, that means it will have a lowest stopping potential. So diagram A will be correct in this case. Lower saturation, lower stopping potential. Higher saturation current, higher stopping potential. P will have higher stopping potential. So A will be the correct choice. Now come to job number 9. Two blocks are shown here, two identical rectangular rods of metal of thermal resistance are welded end to end as shown in figure. 10 joule of heat flowing through the rod in 2 minutes. How long would it take for 30 joules of heat to flow through the rods if they are welded as shown in the figure? Initially this type of welding is done. Then it is like this. That means this is in series form of resistance. This is a parallel formation of resistance, that is to be noted here. Now we can do by simple approach, that is Q1 will be 10 divided by 2, 10 joules divided by 2 minutes, that means 5 joules per minute will be the rate of flow when it is connected in series. Here all other surfaces are insulated. Of course it has to insulate, otherwise all direction heat will flow. Now one direction, say this direction, heat is flowing, that is Q bar is the rate of heat flow. One end is 0, other end is 100 degrees Celsius. High temperature to low temperature will be the direction of flow. Now similarly for this diagram, we can write down temperature difference theta 1 minus theta 2 divided by total resistance will be twice R, because R plus R. Now when it is arranged in this way, resistance will be parallel in connection. I mean here resistance will be R equivalent is product of the resistance divided by R plus R. I mean R by 2 will come. Now here heat flow is given, the heat amount is given 30 joules, and we have to see how much time it will take to flow. Now 30 divided by T will be the rate of heat flow. This heat flow rate will be same for both the arrangement. Now the heat flow, Q1 is the heat flow rate here, and Q2 will be the rate of heat flow, that is 30 by T will be the rate of heat flow for the second arrangement. Rate flow will be different. Now theta 1 by theta 2 divided by R, these divided by twice R is nothing but 5 joules per second, as it is known here. For this arrangement, in series arrangement, 5 joule per minute. That means these can be replaced by 5 joule per minute. I mean, if you rewrite this in this fashion, dividing by here, multiply 2 and another 2 here, that means it will become 4 times of same expression. This theta 1 minus theta 2 divided by 2R. Instead of this, we can put 5 joules per minute. That means 20 joules per minute will come here. 20 joules per minute. And here that is 30 by T. Already we have taken here 30 joules per time. Time is unknown here. Solving from here, we can see that it will take 1.5 minutes time to flow 30 joules of heat by parallel arrangement. You can see answer will be B for this case, that is 1.5 minute. Now job number 10. Distance between the centers of two stars, 10 small a. The masses of these stars are capital M and 16 times capital M, and their radii small a and twice a respectively. A body of mass small m is fired straight from the surface of the larger star towards the smaller star. The minimum initial speed for the body to reach the surface of smaller star is, there are 4 choices, we have to find out the correct one. Here objective is that from big star one mass will be thrown, and one mass is fired, and what should be the minimum velocity, minimum initial velocity of the body, so that it will reach to small star surface. Here one thing we have to note down, that two stars are there, so each one has their own gravity field there. That means there will be a position, a null point position will be available. We have to identify, we have to find out first where is the null point between these two stars. One is big, one is small. Let us find out first. Then what is required? That the mass has to fire to cross the null point only. Thereafter that object will go automatically by the gravity field of the other one. Self gravity force will pull the object on the surface. So first job we have to find out the null point. Very simply we can find out the null position, because we know gravitational force expression. Gravitational force for small star is this one, small star, that is G big M dash is the mass of the object which is taken here, divided by x1 square, and that is here it will be GMM. M means 16m divided by x2 distance square, and x1 plus x2 is nothing but total distance is 10a, already given it. It is 10a. Yes, it is given it in the problem. X1 plus x2 is 10a. Now from x2 by x1 we can get a relation, that is 4 will come. From solving here you can get 4. Now put it here, and x1 will be available 2a and x2 will be 8a. That means the position of the null point, from here it is twice a distance away, from here it is 8a distance away. Now if that object is fired from big star, now it has to cross the null point only. That we have to see. Now how to do this? By conservation of energy. Now see how we can do this. Simply we can do now. See this diagram. Suppose you are firing from here to null point. That means you need to supply kinetic energy at this point. That is half a small m v square, the minimum velocity which is required, plus total potential energy due to this one as well as due to this one. The total potential energy when it is here. Now when it will reach to null point, velocity, kinetic energy will be 0, but potential energy due to both the stars has to be calculated. Now see the equations. Kinetic energy when it is on the big star, that is minimum energy. Potential energy on that star on the surface, that is PE. It is taken 2 because symbol I have given here 2 here, and this is 1. That's why potential energy of the surface, and due to both the stars, potential energy calculation has to be done on big star surface due to both the stars. Now come to right side, potential energy at null position, that is to be calculated due to both the stars. Both the stars will get involved. Let us see how we can do this. Half m v square is the kinetic energy. Now on the big star, potential energy on the surface will be, because its radius is twice a, minus gmm by distance, radius twice a, and the small star up to that distance, I mean here distance is 8a. Now that will come here, minus gmm by 8a. So that means total potential energy on the planet, on the star 2 is this one. Now when it will reach to null point, their potential energy of the big star will be minus gmm by 8a, distance will become 8a. Already you have seen that x1 is twice a and x2 is 8a, then the 8a will come here, and small star, it will be gmm by only twice a, because distance is twice a, already know x1 is twice a. Now from this we can simplify, and it is not a very big calculation, simple calculation is there. We can find out v square, you can simplify this taking left side right side, so all these potential to right side and kinetic energy left side, that means m is, you will get v square equal to this type of expression, 45 by 4 gm by a, and all these are given parameters. It will come in terms of given parameters, that is v will be root under 3 root 5 by 2 root under gm by a, or you can take this 5 into this, that is root under 5 gm by a will come, 3 divided by 2 outside root under, that will be the answer. Answer C will match with this. You can see here 5 has taken inside 2 by 3 root under 5 gm by a, that will be the answer. No, the answer will be this one, B. B will be the answer. You can see here 3 by 2, B will be the answer. Check this. This 5 will be inside this, 3 by 2. Now come to next job. There is a mild steel wire of length twice big L and cross sectional area A is traced well within elastic limit horizontally between the two pillars. Two pillars are there, one string is here, in between one mass is hanged, that is small m. Due to that, its profile has become like this. I mean, it will sink here and in this form. Now we have to find out m is suspended from the middle points of the wire, strain of the wire, and the x is very less compared with L. Now what to do? Now this length is how much? This length will become, each length is L. From here to center is L, here to here, total is twice L. This length will be root under L square plus x square. You can solve in this way. This length will be root under L square plus x square, because this is x, right angle triangle. Now here total length will be 2 times of this length, root under L square plus x square, and minus twice L initial length, that will give the delta L. Now from here just take out L square common and outside, then one L will come, and this type of formation will take place, 1 plus x square by L square whole to the power half. Use binomial. Now outside twice L will be there within bracket. If you use binomial, then 1 plus half x square by L square as usual come, and higher terms. You know that binomial will give next square, I mean x to the power 4, L to the power 4, all these things. This higher term can be neglected because of this ratio itself is a very small, minus 1. So simplifying all this here, 1 gone, 2L multiply, this one L 2 cancels, that L x square by L square, or x square by L will come. In the left side delta L. We are interested about delta L by L, because strain by L means twice L, total length is twice L. Delta L divided by twice L, that means it will here twice L will come, here also twice L, that means 2L square will in the denominator. I mean we will get x square by 2L square will be the relation, x square by 2L square, that is the answer here. X square by 2L square. A is answer here. Now next job. that is now here is a potentiometer, no meter bridge, sorry, meter bridge. Figure shows a meter bridge where AC has a uniform cross section area. The length of the wire is 100 centimeter. Y is standard resistor. X is a standard resistor of 4 ohm and Y is a coil. Now when Y is immersed in melting ice, the null point is 40 centimeter from point A. When the coil Y is heated to 100 degrees Celsius, 100 ohm resistor has to be connected in parallel to Y in order to keep the bridge balanced at the same point. That means it is a meter bridge, 100 centimeter is the standard length. Now here as we know that x by y equal to we can write resistance of x and resistance x by y that is equal to the null point length, that is say L divided by 100 minus L. That is the general formula for this. Now let us see how we have done this job. Now when it is at 0 degrees Celsius, x by y, its null point is at 40 centimeter from left side. That means 40 divided by remaining is 60, that means 4 by 6. That means y will be 4, x is 4 given, y will be 6 ohm. Now when temperature raised to 100 degrees Celsius, y will become you know that resistance will increase like R naught bracket 1 plus alpha into delta T. In the same way here it is 6 1 bracket 1 plus alpha into 100 degrees Celsius. That will be the resistance at 100 degrees Celsius for Y. Now that is taken here Y dash. Now initially it was 6, now it will be Y dash. Now 100 ohm resistor has to be connected to get same null point. I mean parallel 100 ohm resistance means that equivalent resistance will become Y dash 100 divided by Y dash plus 100, and this is the present resistance. Now as the balance point we know x by the new resistance, that is R, will balance according to question the previous value, that is 40 by 60 as it is given in the question. It will match with the previous null point. That means we can put R in terms of all these. R will be here R is known y dash 100 y dash divided by y dash plus 100, that one, this one, this is R, and we know that x is 4, this is again it will give this type of expression, that is this relation will be equal to 6. You can check here x is 4, this 0 0 cancels, 4 4 cancels, then R is again 6. I mean R means this one, y dash 100 divided by y dash plus 100. Solving here you can get y dash equal to 600 by 94 ohm will come. 600 divided by 94, and y dash is known to you. I mean y dash relation is known to us, that is 6 bracket 1 plus 100 alpha. So instead of this we will put 6 bracket 1 plus 100 alpha. From here 600 alpha is this much. Solve here, you will get 36 by 94, and alpha will be 6.3 into 10 to the power minus 4 Kelvin per Kelvin. 6.3 into 10 to the power minus 4 per Kelvin. You can see answer here. This one. A is the choice here. Now next job. The circuit shown in the figure containing two diodes, each with a forward resistance 50 ohm and with a infinite backward resistance. If the battery voltage is 6 volt, the current through 100 ohm. I mean, current cannot go infinite resistance in the backward reverse direction, so this route cannot be allowed. Current will go like this. Here resistance is 50 ohm as it is given for forward resistance 50 ohm, 150 plus 100. 250 plus 50, that is 300. 6 divided by 300 will be the amount of current. How much it is? 6 divided by 300. 6 divided by 300 will give you point. It will give you 0.02 ampere. That will be the answer. Simple job. Next job. 2 point masses 0.3 kg and 0.7 kg are fixed at the ends of a rod of length 1.4 meter and of negligible mass. The rod has no mass, negligible mass. The rod is set rotating about an axis perpendicular to its length with a uniform angular speed. Speed is uniform, that is to be noted. The point on the rod through which the axis should pass in order that the work required for rotation of the rod is minimum. Minimum work is needed to do this. What should be the location of the axis of rotation? Is located at the distance. Choices are here. Now solve this problem in this way. Now total length of the wire rod is 1.4 meter, massless wire. 0.7 kg mass here and here 0.3 kg. This distance is x, this will be remaining distance, L minus x. And total distance is given, L is 1.4. Now as you know, moment of inertia, point mass into distance square, m 0.7 into x square plus 0.3 into L minus x square. Now work done equal to change in kinetic energy, half I omega square. Now from here we want to get minimum situation, that is dw by dx will give 0. Now moment of inertia, this part can be differentiated, that is 0.7 into twice x will come after differentiation plus 2 into 0.3 differentiation of this one will give 2 times this x square is there, 2 times L minus x, and when you will differentiate once here you will get minus 1. So solving here as left side 0, solving here we can get x equal to is coming 0.24 meter from left side and right side will be 0.98 meter because total is 1.4 meter. You can see in this diagram in this that is 0.24 and 0.98. 0.24 and C will be the choice here because you see 0.98 meter from where? From 3 kg mass. You can see in the diagram 3 kg mass, this distance is 0.98, that is given in the answer. 0.98 meter from mass 0.3 kg, that should be the answer here. Next come to 16. Job number 16. The linear time varying magnetic field B within as a function of t exists in a circular region of radius small a and is directed into the plane of the paper as shown in the figure. The magnitude of the induced electric field at point P at a distance smaller from the center of the circular region. There are 4 choices. 0 decreases as 1 by r, increases r, decreases as 1 by r square. Now as we know EMF we can write close integration of E dot dl. Then this change in magnetic field will give electric field and EMF. that means minus d phi b by dt we know. Now here d phi b is given, that is d phi b by dt we can phi is given as a b is a function of time, and phi means b dot a area is fixed, so area will come out from this. So you can write e 2 pi small r around that circular path. Say p is outside this will be the radius here. That means e 2 pi r equal to a d phi b as a function of time dt. Now here a means pi a square, because magnetic field available within this zone only, that is a is the radius, and e we can write pi a square divided by 2 pi r is greater than a here, dB function of time by dt. Now pi cancels, a square will remain, and 1 by r is the relation here. That means e is e varies with 1 by r. Answer B will be the correct one here. B, this one.